It is Monday, February 16th, 2026. And if you're looking at your calendar this morning, you might be feeling a very specific, heavy sort of gravity, that honeymoon phase of the semester, that is officially in the rearview mirror.
Gone. Completely gone.
Today is the day the rubber really meets the road. We're shifting from just talking about software engineering, the theory, the ideas, to, well, actually having to deliver it. And the theme staring us in the face today is pretty blunt.
It is. It's programming is hard work.
Exactly. This is that moment when all the theory stops being abstract and it suddenly becomes a very real, very long to-do list.
And to help you navigate this, we're pulling from a really fascinating stack of sources today. We've got two absolute titans of the field, Frederick Brooks and his legendary The Mythical Man Month.
Chapter 16, specifically.
And we're pairing that with the, let's call it the battlefield wisdom of the pragmatic programmer, Chapter 9.
It's such a cool contrast of perspectives, isn't it? On one hand, you have Brooks giving us this like high-level philosophical reality check.
He's basically saying, there is no magic wand, so stop looking for one.
Right. And then you have the pragmatic programmer guys who are like, okay, sure, it's impossible, but here's your survival kit so you don't drown.
It's the why it hurts versus the how to handle the pain. And right in the middle of these two massive texts, we have something very specific for your current situation.
A stern warning.
A very stern warning from the Class 14 slides about retentiveness and, how to survive your upcoming Scrum meetings without completely wrecking your team.
So our mission today is to unpack this whole no silver bullet idea, because it's way more than just a catchphrase, then dig into the nitty-gritty of running a pragmatic project, and finally, look at exactly what you need to do to make sure your team doesn't crash and burn.
Let's dive in.
Let's start with the heavy hitter, Frederick Brooks. Chapter 16, No Silver Bullet. Now, to the uninitiated, this sounds like we're hunting werewolves.
Yeah.
But in software engineering, this concept is, well, it's famous for being kind of a downer, right?
It is often read that way, yeah. It's definitely a splash of cold water. Brooks's core thesis here is it's something developers have been fighting against for decades. Yeah. He essentially says there's no single development, no new tech, no management trick.
Not even a shiny new coding language.
Nothing. Nothing that promises even an order of magnitude improvement in productivity, reliability, or simplicity. Not within a decade.
Let's just pause on order of magnitude. We're not talking about a little 10% gain here.
No. He means a 10-fold improvement.
Yeah.
10 times faster. He's saying we're not going to suddenly get 10 times better just because we invented a better text editor.
That feels so counterintuitive, though. I mean, technology moves so fast. We're sitting here in 2026. We have way better tools than we did in the 90s. Why does he think we're stuck?
So to explain that, Brooks breaks all software difficulties into two distinct categories, essence and accident. And if you don't get this distinction, you really don't get software engineering.
Okay, let's unpack that. Essence versus accident. What's the difference?
So the essence is the stuff that's inherent to the nature of software itself. Yeah. This is the inescapable stuff.
The hard part.
The really hard part. You've got complex data sets. You have all these relationships between data. You have algorithms, function calls. It's the conceptual construct. The hard part isn't typing the code. It's the specification, the design, and the testing of this abstract concept.
Right. It's the thinking. It's figuring out what you're building and how the logic flows. It's the puzzle.
Precisely. Now, accident refers to the difficulties in just producing that software.
Okay, like what?
Things like syntax errors, waiting for code to compile, or dealing with clunky hardware. And Brooks argues that most of the big gains we've made in the past, like high-level languages where you don't have to manage memory or object-oriented programming, those only solve the accidental problems.
Ah, I see. So moving from punch cards to an IDE made it easier to write the code. It removed the accident of clumsiness. But it didn't make the logic of the program any easier to figure out.
Exactly. We've removed the clumsy barriers, but we're still left with the core problem. Software is complicated, and you can't tool your way out of a logic problem. He actually lists 4 villains of software that make this essence so hard.
The 4 villains. I love how dramatic that is. Let's run through them because I think every developer has met these guys. First up, complexity.
Complexity is the big one, and it's really specific. Brooks points out that no two parts of a software system are the same. If they were,
you just make it a function and call it twice.
You just make it a function. In manufacturing, if you're building a car, you make the same door 10,000 times.
Right. Scaling up is repetition.
Exactly. But scaling up software means increasing the number of different elements all interacting. And because every part is different, the complexity grows exponentially, not linearly.
It's a house of cards where every single card is a different shape and size.
A perfect analogy. Okay, villain number 2, conformity.
This one really resonated with me. It's this idea that software has to conform to us, not the other way around.
And it's incredibly frustrating for engineers. Think about physics. Physics has these beautiful unifying principles.
Right. An electron is an electron.
Everywhere. It behaves the same way in New York as it does in Tokyo. The laws of the universe don't change on a whim.
But clients do.
Clients do. Tax laws do.
Yeah.
Business processes do. Software has to conform to these arbitrary human institutions, and it has to bend and twist to fit them.
You can't just tell the finance department, sorry, the code doesn't want to do that. You have to make it work. Okay, villain 3, changeability.
This is the curse of being successful. Software is infinitely malleable. A building, once it's built, it stays a building. You don't ask the architect to move the basement to the roof 6 months later.
No.
But software, as soon as users start using it, they want more. They want new features. The world changes around it. It's never done.
It's just released for now.
Precisely.
Yeah.
And that constant change just breaks things.
And finally, villain number 4, invisibility.
This one is profound, and I think it's often overlooked. You cannot see software. You can see a building. You could look at a blueprint and see a geometric representation of a floor plan.
You can point and say, that wall is in the wrong place.
Right. But software has no geometric presence. You can see lines of code, sure, but you can't see the structure of the execution. You have to visualize it with these, directed graphs and the flowcharts.
It's like trying to draw a map of a conversation.
And that invisibility makes it incredibly hard to communicate the structure to your team. It's hard to find the loose ends when you can't see the whole thing at once.
Now, in the reading notes, there was a really interesting point about AI in this context, because everyone today, especially in 2026, thinks AI is the silver bullet.
Of course.
We have tools like BitBuddy, we have code generation, but the notes suggest Brooks might not agree.
Yeah, the notes make a very sharp reality check here. They suggest that AI, at least in the forms we see now, is not a silver bullet for the essential difficulties.
So it's good at the accident part?
Exactly. It's great at generating syntax, closing brackets, writing boilerplate code. It can solve problems that humans used to solve, but it doesn't necessarily solve novel conceptual problems. It's not constructing a brand new complex system from scratch. You still have to do the thinking.
Okay, so that is the hard truth. Software is inherently complex, invisible, constantly changing, no magic fix, but we still have to ship a product this semester. We can't just throw our hands up and quote Brooks.
No, deadlines wait for no philosopher.
So let's pivot to the survival guide. The Pragmatic Programmer, Chapter 9. Pragmatic projects. If Brooks tells us why it's hard, these guys tell us how to not go crazy doing it.
And it all starts with team dynamics. They use this famous metaphor, no broken windows.
I love this concept. This comes from urban planning, right?
Exactly. The theory is if a building has a broken window and nobody fixes it, it signals that no one cares. Soon, more windows get broken, graffiti shows up, the standards collapse.
And in code, it's the same thing. What's a broken window in a GitHub repo?
It's that one compiler warning you always ignore. It's a variable named X when it should be usered. It's that huge block of commented out code that someone was too afraid to delete.
Oh, okay.
If one person leaves a mess like that, the standard for the whole team just drops. It's contagious.
So quality is a team issue. You can't just say, well, my code is clean, too bad about yours.
No. You have to police the environment together. You fix the windows as soon as they break. And part of that is building an identity. The readings talk about generating a brand for your team.
A brand, like a logo.
A name, a logo, a sense of us. Put it on your documentation. It sounds trivial, but it creates this sense of ownership. It turns a group of random students into a development shop. It changes the psychology from I have to do this homework to we're building this product.
And within that shop, you need roles. The notes talk about a technical lead and an administrative lead. Why is it important to separate those?
Because they require different brain spaces. The tech lead is the architect. They're focused on design, on arbitrating the how do we build this debates.
Mm-hmm.
The admin lead is focused on resources, scheduling, the are we on time questions.
And if you try to make one person do both,
they'll burn out. Or one side will suffer. You'll get great code delivered 2 weeks late or terrible code delivered on time. You need that balance.
Now, there's a quote in this section that I absolutely love. It's about automation. Civilization advances by extending the number of important operations we can perform without thinking.
It's a brilliant quote, and in coding it means don't do manual processes twice. Compiling code, running tests, packaging a release. That should be a script.
A cron job.
A cron job, a makefile, something. Because if it's manual, humans will mess it up. Or, more likely, you'll just skip it because it's 2 a.m. and you're tired. The notes are very clear. Compiling and regression tests must be automated.
Which brings us to the mantra of the section. Coding ain't done till all the tests run.
A rule to live by. And to make sure those tests are actually worth anything, they suggest something really fun here. The Project Saboteur.
The Saboteur. This sounds like a reality TV show twist.
It's a fantastic idea. You introduce a saboteur to the team. Maybe one person takes the role for a day, and they intentionally introduce a bug. They change a logic operator, delete a dependency, something subtle.
And the goal isn't just to be a jerk.
No, the goal is to verify. Do the tests actually catch it? If the saboteur breaks the code and the build still passes, your tests are worthless. You have a false sense of security.
That is bold. You're forcing yourself to trust your safety net by trying to cut it. And speaking of tests, can we get the quick explain like I'm 5 on the types? Unit integration and validation.
Sure. Unit testing is checking the bricks. Does this one single function do what it says it does? Integration testing is checking the wall. Do the bricks hold together? Does the database talk to the API?
And validation?
That's checking if the wall is actually what the user wanted in the first place. You can build a perfect wall, but if they wanted a window, you failed validation.
So it's not just about being bug-free, it's about solving the user's problem.
Exactly.
Oh.
And that leads to the final point, user expectations. The reading suggests you should aim to slightly exceed them. It's about delight. A tooltip they didn't ask for. A keyboard shortcut. It generates goodwill.
And goodwill with your professor acting as the client is. Gold.
Absolute gold.
Okay, so we have the philosophy from Brooks and the toolkit from Pragmatic Programmer. But now we need to talk about the specific warning for this class. We're looking at a slide from Class 14 titled, How Do We Make Progress?
This is a critical pivot. We're going from general advice to very specific class instruction. And it opens with a quote from George Santayana. Those who cannot remember the past are condemned to repeat it.
A classic. Why is that on a software engineering slide in 2026?
Because progress depends on retentiveness. The slide is a direct warning to you students. If you change things without remembering why you made the previous decisions, you're just spinning your wheels. You're in perpetual infancy.
Just reacting, not building. And there's a very specific consequence listed here for the teams about their meetings.
Yes, it gets very practical. It says if team members are oblivious during Scrum meetings, if they ignore announcements or disregard decisions, the project will suffer.
That's the Santayana warning. If you're sitting in the Scrum meeting scrolling on your phone, and then 3 days later you write code that contradicts the team's decision, you're actively damaging the project.
You're forcing the team to repeat the past. Wait, didn't we decide not to use that library? Now we have to have the meeting all over again.
Yeah.
You can't just be a code monkey who ignores the context.
It sounds a bit intense, but to balance that, the notes include a reflection from a former student, Alex Carney.
Which is important context, yeah. He compares the class to Dartmouth's DALI program and talks about the incredible camaraderie. They had breakfast together, went to karaoke nights.
And that's the flip side, isn't it? The work is hard, the coordination is demanding, but if you actually engage, you build this amazing bond.
Exactly. The difficulty creates the bond, but only if everyone is pulling their weight.
Okay, let's get down to brass tacks. Logistics. The road ahead for the next week is jam-packed.
It really is. This is where the planning phase ends and the doing begins.
First up, Tuesday, February 17, that's tomorrow.
Your deadline for initial requirements understanding. You need to have your questions sent to the client. If you have ambiguities, ask now.
Then, Friday, February 20 at 8 a.m., an early morning deadline.
A big one. Deliverables are due. You need your core values and mission signed, your standards documented on the wiki, and the wiki sections have to be implemented, not just planned.
And then, the big one, Monday, February 23.
The starting gun. First sprint planning begins.
Okay, for this sprint planning, we have some very specific rules from ScrumWise. Let's break these down, because they are designed to prevent disaster. Rule number 1, the 2-week rule.
This is non-negotiable. No task can be estimated at over 2 weeks. If you look at something and think, that's a 3-week job, you have to break it down.
Why? Why not just have one big task?
Because a 3-week task is code for, I don't really know how long this will take. It's a guarantee of failure in a 2-week sprint. Breaking it down forces you to understand it.
It forces you to see the essence we talked about. Next up, workload.
Each person needs 20 hours of tasks defined. You are responsible for making sure you have enough work. Don't wait for someone to assign it.
And then 2 design concepts, orthogonality and loose coupling.
These are survival skills. Orthogonality means arranging your work so you don't trip over each other. If I change my code, it shouldn't break your code.
Okay, and loose coupling.
That means you aren't stuck waiting for someone else. You don't want a situation where you can't start your work until I finish mine. That's tight coupling. It kills a sprint.
And the ultimate goal for every sprint.
A working version, not a partially coded version.
Yeah.
Not an it compiles on my machine version, a real working version.
That is a high bar.
It is. But that's the industry standard.
So to recap our depth dive today, we've accepted the hard truth from Brooks that software is inherently complex. It's an essence problem.
We've picked up the toolkit from the pragmatic programmer. No broken windows, automate everything, test ruthlessly.
And we've heard the Santayana warning from the class notes. Be retentive. Pay attention in Scrum. Don't make your team relive the past because you weren't listening.
And remember, the reward for all this isn't just a grade, it's that camaraderie. It's becoming a team that can actually handle this complexity.
Here is a final thought for you to chew on as you head into this week. Brooks argues that one of the 4 villains is invisibility, the fact that software is so hard to visualize.
Right, the floor plan you can't see.
So, as we move toward a world of AI-generated code, which you have access to with the BitBuddy tool, if we start writing less code ourselves and reviewing more AI-generated code, does software become even more invisible to the creator?
That is a fascinating question. If you didn't write the line yourself, if you didn't struggle through that logic, do you really have a mental model of it? Or does the AI just add a new layer of essence difficulty?
Does it make the accidental part easier, but the essential part harder? Are we building a skyscraper where we don't even know where the support beams are? Something to think about.
Indeed. Proceed with caution.
All right, you have your deadlines. Tuesday for requirements, Friday for the wiki, Monday for the sprint. Go break up those tasks and make sure they fit that 2-week rule. We'll see you in the next deep dive.